Today, we are going to discuss the different combination of circuit. Different combination means series, parallel, etc. All combination used in the household circuit. Today we are going to discuss. So today our topic of discussion: series circuit, parallel circuit, etc. All of this. Now the thing is, what is series circuit and what is parallel circuit? First of all, here you can see two bulbs. I'm writing two bulbs. One is B1, another is B2. Two bulbs B1 and B2, they are just connected in series combination. And here current is flowing from positive terminal to negative terminal. Current will be flowing from positive to negative. Now the question is, how can you identify that two bulbs are connected in series? Now the thing is, whenever we are connecting two bulbs in series, that means these bulbs are having their own resistance. Means here bulb B1 is having their own load resistance. Let me draw it properly. Now here you can see when the current is flowing through both bulb B1 and B2, when the current is flowing. Now the current is flowing, that time current is choosing only single path. Means the same amount of current is flowing through B1 and same amount of current is flowing through B2. That means here when the current is flowing, the same amount of current is flowing through R1, same amount of current is flowing through resistance R2. What are these R1 and R2? R1 is resistance R1 and R2 both are resistance. Now when the current is flowing from positive terminal to negative terminal of a circuit, current is choosing single path. That means how can you identify? Means in a circuit, if the current is not divided, that means if in a circuit the current is not divided, means same amount of current here is same amount of current is flowing through the bulb B1 and B2. Through both the bulb B1 and B2, the same amount of current is flowing. Bulb B1 and B2. That means in this circuit, the same amount of current is flowing through the bulb B1, B2. That's why it is in series. That means in series circuit, here current is same for the whole terminal. As the current is same for the whole terminal, that means the first point is that in series circuit, current will be same throughout the path. That means in a series circuit, which thing will remain constant? Current. In a series circuit, the thing that will remain constant, that is what? That is current. Now, the first point, that means we get to know if the circuits are connected in series, the first thing, current will be same. Current is same throughout the circuit. Throughout the circuit, current is same. Now, as the current is same throughout the circuit, the amount of current bulb B1 will get, the same amount of current bulb B2 will get. The amount of current the bulb B1 is getting, the same amount of current bulb B2 is getting. But the thing is, their resistance R1 and R2 are not same. Resistance R1 and R2, these are not same. That means, as we know from Ohm's law, that voltage equals current into resistance. This we know all. As we know that voltage equals current into resistance, that means what? Same current flowing through bulb B1. Resistance is different, so across the across the bulb B1, different amount of voltage drop will be there. Similarly, as same current is flowing through the resistance R2, so across the bulb B2, voltage drop will be different. That means what is the main thing in series connection? Current remains same. In series connection, current remains same. But what we know? Let me draw a resistance first. Here. As we know that in series connection, current is same throughout the whole circuit. Still the current is same, but as we know from Ohm's law, voltage equals current into resistance. So for first bulb, resistance is R1. So voltage across that first resistance will be V1. Voltage across the first resistance will be what? V1. As we know, for second bulb, current is same but resistance is different. Current is same but resistance is different. That means what? Voltage across the resistance R2 is V2. So what's the summary? Summary is that in series connection, the thing that will be remaining same, that is current. In series connection, current will remain same. Now as throughout the path current remains same, but as resistance are different, R1 and R2, as resistance are different, so according to Ohm's law, we will get different voltages. Different voltages, I mean to say, suppose two resistance are there or two bulbs are there connected in series combination. That means if in series connection, you can see if same current is flowing, as you can see same current is flowing, that means across the bulb B1, voltage is what? Different. Current is same but voltage is different, V1. Here across the bulb B2, current is same but voltage is different, V2. And as usual, you know, resistance are also different. But the thing is, one interesting fact you might be knowing, as throughout the path you can see same current is flowing. Throughout the path current is same. Now they are in series. In series connection, one is connected with another bulb. Now if I just, now both bulbs are glowing. Suppose the both bulbs are glowing. If I just erase one bulb, if I damage one bulb B2, bulb B2 stops glowing. Suppose the bulb B2 stops glowing. What will be happened? Simultaneously, you can see if any of the bulb B2 stops glowing, then as usual, as a result, you can see bulb B1 also stop glowing. That means in series connection, these bulbs or any kind of instruments are depending upon each other. Bulbs are depending upon each other. Bulbs are depending upon each other. Depending upon each other means if one bulb stops glowing, other bulbs connected in series, it will also stops glowing. Other bulbs also it will be stop glowing. That means in series connection, we get to know three things. First, here current will be remain same, but voltages and resistance as well as voltage, these will be different. And the things we get to know that In series connection, the instruments that are connected in series, that will be depending upon each other. Now the formula we know for Ohm's law, that voltage equals current into resistance. We will discuss in another video in detail about Ohm's law. Voltage equals current into resistance. Now suppose for that case two conditions, that two resistance are connected in series. Now we know that then voltages will be added in series combination. Now we know voltage equals current into resistance. Then for the first bulb, what we will get to know? For the first bulb, we can write current into resistance of the first bulb plus current into resistance of the second bulb. Now, if you take common of I, then I will be cancelling out in each side. IR equals, if I take common I, R1 plus R2. Now I cancel out. So we can write as a result, in series combination, resistance will be added. That means in series combination, net resistance will be always added. Net resistance will be always added. That means you will see during Diwali time, during Diwali light, the resistance, if you will cut if any one of the bulb, other bulbs will stop glowing. Let's do a numerical problem on series connection, then you will get to know it more easily. In our next video actually we will discuss about, first I should give that video previously, that Ohm's law and parallel combination. Before that, let's do a problem on series combination. Now pardon me for my drawing. In series combination, one resistance is connected in 1 ohm, another 2 ohm, another is 3 ohm. Now what we know, in series connection, resistance will always be added up. So here three resistors of resistance 1 ohm, 2 ohm and 3 ohm will be added up. So net resistance will be 6 ohm. That means in series combination, resistance are always used to be added up. Means, and the another thing, current will be same, but voltage drop across one resistance will be different from voltage drop across other resistance. Similarly, here you can see voltage drop across 1 ohm, 2 ohm and 3 ohm, they are different, right? So that's all. In our next video, we'll first discuss about Ohm's law and parallel combination. That's it for today. Thank you.